Hi everyone, so this is video number 3 with our mass spec mechanisms. In this one I'm going to start talking about our ethers. Now our ethers can undergo two different types of fragmentations, one being heterolytic cleavage and the other being alpha cleavage or homolytic cleavage. I'm going to split that into two different videos so I don't have a super long one. And for this one we're going to be focusing on that heterolytic cleavage. Now remember with our heterolytic cleavage, I'm going to be using double barbed arrows where I'm moving 2 electrons at a time. And in this example, we're going to be looking at this specific ether where it is not symmetric. What I mean by that is the carbon groups that are bonded to that oxygen are not exactly the same. So we're going to have to be looking at multiple different types of fragmentation patterns. And I've already gotten that set up for us here. So there's going to be 2 different fragmentations since we have 2 different alkyl groups. Before we start fragmenting, the first thing you guys better be looking at in your mass spec is the molecular ion peak. So our molecular ion peak is going to be, and this is with every single functional group, not just ethers. This would be the very first thing you do if you're ever given a mass spec. I don't care what it is. Your molecular ion peak is going to have a mass to charge ratio equal to the molar mass of the compound, all right? Now, what I'm showing you here is the molecular ion that forms, okay? We always have to ionize our structure before we can start fragmenting. So the very first thing I would want to know is what is the mass to charge ratio of this structure. So let's go ahead and figure that out first. So I have 16 for oxygen. I have 1, 2, 3, 4, 5, 6. I have 7 carbons. So that is going to be 84. And then I have 3, 6, 9, 12, 14, 15. I'm getting 16 hydrogens. Let's see. So okay, so my mass to charge ratio I'm calculating is 116. And in the second video, I'm going to show you the mass spec so we can confirm that. So that is the very first thing you better be doing every single time you get a mass spec, okay? All right, now we're ready to start fragmenting. So what we're going to do is we're going to start with the propyl group for no particular reason other than I wanted to do it first. And we are going to cut or fragment the alpha carbon oxygen bond. Now the alpha carbon is going to be the carbon bonded to the oxygen in our ethers. We're going to break this bond and give both of those electrons to the oxygen. Why do we give it to oxygen? Well, oxygen is more electronegative, so it wants those electrons. And the first set of fragments that we are going to form is the oxygen that has the carbons where we didn't break anything. That oxygen had a lone pair. It just gained another lone pair from the electrons from the bond, and then it still has a radical. Now this oxygen is going to be neutral now. If you would like to prove it to yourself, calculate the formal charge. You'll see it's 0. And then the other fragment is going to be the carbons of the isopropyl group, where the middle carbon was the carbon that was bonded to oxygen. Since it lost that bond, it now is going to have a positive charge. Since that is where the cation is, that will be the species the mass spec will see. So that is the one I'm interested in knowing the mass of for the mass to charge ratio. So my mass to charge ratio for a propyl group is going to be, let's see, we got 3 carbons, so that's 36, plus I should have 3, 6, 7 hydrogens here. So I see we should have a mass to charge ratio of 43. So I have 2 masses so far I'm keeping track of to look for my mass spec. I have 116 for my molecular ion peak and then 43. So that's our first heterolytic cleavage. We have another alkyl group, so we're going to do the exact same thing, where this time we're going to lose our butyl group. So we're going to break the carbon-oxygen bond, give those electrons to the oxygen. I guess I should have called that a sec-butyl group since that's what it is. Now, those carbons are no longer bonded to the oxygen. That second carbon should have a positive charge since it lost the bond to oxygen. And then the other species I'm going to form is the isopropyl group that does still have that oxygen, which now has 2 lone pairs and it still has that radical. All right, this is the species that I know the mass spec will see since it has that positive charge. Now for our mass to charge ratio, I have 4 carbons, so that's 48. And then let's see, we should have 3, 6, 8. I'm getting 9 hydrogens, so it should give me 57. So I should have a mass to charge ratio of 57. So that will be the second peak I look for heterolytic cleavage. All right, so that's all the possible fragmentation I can do with heterolytic cleavage. Check out the next video for homolytic and then looking at the mass spec for this structure.